To start, I've noticed that I usually start talking before I get the green light, and the first few seconds of the video get cut off. Anyway, welcome to another CodeZone. It's episode 27, and I know those hanging around may have just been stung by an advert, so I will just keep on talking gibberish for the next 1 minute or so. Who we've got so far? Danny Cron, hello. Myself, hello. Dan Destine, hello. Yes. Did you get a different haircut? No, I've just washed it today. Alta, hello. Yes, Christoph, hello. Now, today I'm going to do something a little bit different. We're going to do some code, so it's all back to normal, but we're not jumping into space thing. There was never any sort of intention that CodeZone would be exclusively about space thing, and I wanted to talk about something a bit different today, because there's an issue that keeps arising. So I'm just going to wait till Dan Destine tells me that the ad has finished. Because I've got a feeling Dan Destine's input might be quite useful in this, and quite a few others, because we've had a lot of different attempts at trying to solve a particular problem that's not unique to the Pixel game engine. And as the title of the stream suggests, it's investigating tile rendering artifacts. So what we're going to look at is how we can render some tiles very quickly in the Pixel game engine. In fact, I've already got the code ready, we don't need to sit through that. But then I'm going to show you what some of the problems are, because it keeps popping up. Lots and lots of people are doing exactly the same thing, and they're doing it right. They're trying to draw tiles, and they're seeing all of these unwanted lines. This hopefully will be the start of a bit of an investigation. Now, I've tried on several occasions to squash this feature, or bug. With various different ways of thinking about it, but the problem is I've left in all these remnant bits of code and stuff's not quite right, and it's actually introduced other bugs and it's removed other features, so we need to kind of repair the Pixel game engine as well. So we're doing a bit of Pixel game engine maintenance tonight, but with an interesting look at how we can sort out this problem with artifacts and rendering tiles. So I'll just show this little program that I've got to start with. Oh, hi Megarev. Showing this little bit of a program to start. It's very simple, there's nothing to it. We load a tile sheet, which has 4 tiles on it, 16 by 16 pixels. I'm throwing in a tile transform view just because it's easier to move things around, makes the code less. I set up a tile transform view here. You can see I specify the tile width to be 16 by 16, and I load the image. Then, as we do with all of the transform view extensions, we pass in some mouse stuff so we can move it around. I'm clearing the screen to cyan, and then I'm drawing as a decal the tiles that I'm interested in drawing. And we'll run this, and we'll see what happens. Yeah, so there we go. Alter is to add a gutter or buffer around it. I don't like that idea, and I wonder if it can be solved with maths, and that's why I thought it's worth throwing open to the chat, because I've had a good go at it, and I think in specific circumstances I've solved it, but I've not come up with a general case, so that's why I think it's quite useful. So here we have, I've got my 2 for loops rendering 20 by 20 tiles. And it might be difficult to pick out on the stream, but there are already some interesting things going on. Let's see if I can make it so you can see. There we go. So if you can follow my mouse cursor, I'll move it slowly down the left-hand side here. We can see that not all pixels are equal. Dun dun dun. Right, so it's going down. Everything looks okay, but look, we've got this row of dots here, which are clearly, well, certainly on my screen at least, they're clearly only half the height of the ones above. So something's going on there. That's the first problem. But as we pan the image around, everything's fine. It looks okay. It's working as tiles should work. No problem at all. Yeah, that's the problem. The gutter doesn't always work either. Yes, it is a common fix. The better fix, and what I'd like to try and do today is to try and maths it out a little bit, determining where we're actually rendering the quads. Now, here's the problem. I'm going to zoom in slightly. Right now, my tiles are 16 by 16. They line up perfectly with the in-game screen. So I'm going to apply a little bit of zoom, and my zoom coefficient, as we can see here, is 1.1. So it's not going to be a factor of 2 zoom. And straight away, we start to see all sorts of problems. So just a little bit of zoom. You can now start to see we've got the cyan is sort of creeping through in the background. So that's more likely a problem that's been introduced recently with how the coordinates for decals are rounded. So we'll have a look at that and see if we can squash that one first. But we can see that the engine is trying to solve a problem that actually has no realistic solutions. If we tell it that it's got to fit a 16 by 16 pixel shape into a 17 by 17 pixel square on the screen, at some point it has to duplicate pixels. Right? That's fine. But what we want it to do is duplicate it but not introduce new colours and new things. We want it to sort of do it realistically and fine. One is sampling on the edge, not being in the inside of the texture. The second issue is if the two rendered primitives share an exact edge with each other. Sometimes pixels can be in neither. Yes, it's a common problem, and it's nice that it's not just specific to Pixel Game Engine. If you Google this line artifact in tile rendering, it pops up in quite a few other engines too, and I think it can be solved by making sure that you restrict the quads on the screen to being sensible pixel boundaries before sending them to the graphics card. At least that's my running theory, and I've had some success with doing that. If any of you remember my jam entry, which was the Meaningless Cog platforming game, I completely rewrote the decal rendering. It's a bit of a cheat. Completely rewrote the decal rendering algorithms in there to handle sort of arbitrary sized tiles. The problem is it's a nasty amount of code. There's lots of inverse transforms going on with how we handle and manipulate the camera, and I want to avoid that. There's got to be an easier way. Is it stuttering? I've got no indication of any dropped frames today. So far, dropped frames 0. Who else have we got here? Oh, right, a few more people. Who have we got? So we've got Nullex Dead Beef. Hello, yes. Christian Seiler. Hello. RHK, hello, yes, welcome. Desp4, hello, yes, Pixel Talk. So we're sort of just doing something a bit different to Space Thing tonight because I wanted to try and solve this problem. A lot of people seem to be having this issue. Alex, hey, hello, yes, good evening. Always good to see Alex here. Is it stuttering? No, it's not. Gruffler, hello. Good to see some recognisable names turning up. This one again. Amoyenesis. Amoyenesis. 666. Hello. TGD, and welcome TGD. TGD's got some excellent demos he's been using the Pixel Game Engine with, and possibly TGD has encountered this problem as well. Have we discussed this before, TGD? I think we might have done at some point. I know it pops up all the time, this problem. So that's what we're going to have a look at trying to address today. So I can keep on zooming, and what we see is it's not that the artifacts get bigger or worse, they just sort of change, and that's because of all of the quantization that's going on and the aliasing to screen pixels and things. There's just all sorts of nastiness happening. Interestingly, it's reasonably consistent regarding panning. It does seem to be a bit pan immune. That's not always the case, though, and what I think we'll probably see today. There we go. So though vertically panning, maybe the compression doesn't actually show you the lines because I'm working on a 1080 screen. Obviously, it's being streamed in 720, so something's got to go somewhere. But if this line here where my mouse cursor is, I'm pointing at the screen. Don't know why I'm doing that. You can see if I pan down, it fills in with black, right? So something that's very strange. That's something beyond our control. The blue lines being I can kind of attribute to how I'm positioning the quad in the background. And to solve this problem, we're going to need to understand a little bit about how decals work too. Yeah, TGD. I thought so. I do sort of, anybody that usually bitches and moans about the Pixel Game Engine goes on my list and gets remembered. So there you go. There's a specific honour for you there. No, he doesn't really bitch and moan. He's been very supportive of the stuff. And he does this excellent exile thing as well. So I've tweeted about it. Got to go and check those out. I'll allow you to drop some links somewhere, TGD, since we're promoting your stuff. Yes, if you're unsure that you can see the lines and blow them up in paint, one of the things that's a little bit tricky is some of the lines look thicker than the others as well. Now, that could just be an illusion due to a small problem that might exist with the Pixel Game Engine. There we go. So I've just now made sure that the default window for the Pixel Game Engine is indeed square. Now, if you didn't know, there is a little bug there, and it's only popped up in a slightly more recent version of Windows, which is rather frustrating. One of the things, you can see the window here, but right at the very top, along the cursor, there is a tiny black line. Do I have... I don't think I have the magnifier. Do I have the magnifier installed? That might be quite useful. Magnifier app. Where's that gone? Oh, here we go. This might completely corrupt the stream and all sorts. I can't see where that's gone. Ah, here it is. So let me pull that on the screen here. There we go. Right. So if I move this a bit, we can see there's a single pixel black line has appeared. And this is affecting the aspect ratio of the screen. And so the Pixel Game Engine is kind of filling it in with a black bar. There's possibly one at the bottom as well. And if we're getting black lines at the top and the bottom, it's telling us that the window that's been created isn't quite wide enough. Hang on, I'm catching up with a few bits of the chat here. Speedy, hello, yes, good. Speedy, we're doing something a bit different tonight. We're having a look at some bugs in the Pixel Game Engine. Right, Magetsub's here. Hello, yes, similar issue. So you can see my cursor going over the Twitch chat now. There we are. I had a similar issue. Also seems to be panning immune with a different rendering engine. Yeah, that's what we were saying, Dulce, at the start. It's not unique to the Pixel Game Engine. I think when I was digging into this, and I found on some obscure forums somewhere late at night one evening, that it's actually a problem with how OpenGL samples the textures. But certainly one of these problems is probably a Pixel Game Engine problem, and we'll have a look today. We'll start playing around with some of the rounding and seeing what happens. Staubfinger Coding Games. Well, that's a mouthful. Good evening from Germany. First time catching a stream. Well, good evening. Good evening from the UK. It's not as hot this week, so those of you watching last week will know it was very hot last week. Yeah, it was a problem with floating point rounding. Now, I think that's only part of the problem, and hopefully if we address that bit today, we will see that there's still a second problem that remains. Anyway, it's interesting being on the magnifier. The only problem with the magnifier is it's blurring. Look, it's applying a filter to the image. And of course, on this channel, we like pixels, so do I have a setting? Can I... No, I can't disable the blurring effect, so that's going to be making life a little bit more difficult. Let's pop you up there for the time being. We'll go and we'll pan here. So as we're panning, what I'm concerned about though is this little black line that's appeared. So if I grab the edge, oh, hang on, that's right behind my my beautiful face, isn't it? Let's put that there. If I go and grab this edge of the window and just tweak it a single pixel really carefully. There we go. Right. So you can see at the top, it disappeared. It disappeared, but we've already started to introduce a rendering artifact. Our tiles have this this gap in between them. So that's interesting. I think that is more likely a rounding error. But what I can see now is, unlike at the start, there's no pixels being squashed anywhere on the screen. So that's firstly one of the bugs we should try and fix, is why is the window 1 pixel too narrow along the edge horizontally. Interestingly, when it was 1 pixel too narrow, we didn't see these artifacts. So all sorts of interesting things to think about. Now here, these lines look thick. Now it looks thin. Now it's thick. So that's going from 1 to 2 pixels. But what we can see is it's actually the edge of the tile is getting thicker, or is the gap between the tiles getting larger? Don't know. Going to have to explore that too. Yeah, so Ozyrix there. Yes, so this is exactly, it's a common problem. Lots of people are having this problem. So it's oh, hang on, I've missed a few chats up there. Oh, TGD, you'll have to post it in the CodeZone Discord, or one of the mods can post the link in the chat. Unfortunately, it's blanked it out for you. Okay. Well, this is one of the things. So, should the window size always be an even number? That's possibly it. And it says, is the window 4.5 pixels or 5? So, that is fundamentally the issue that the graphics card has to try and solve here. It's got to allocate these sort of discrete boundaries to discrete pixels. We're not allowing it to do blending or blurring or anything like that. So if I squash the window even more, well, you can kind of see the artifact. The artifacts are still there, so there's clearly a problem. But that's the gap one is the one I want to solve first, and I think that will reveal a slightly different one. So let's have a look. For now, I'm just going to move the old magnifier over there, so it's not too distracting. So there's nothing in this program other than this loop drawing 20 by 20 things. Now, I'd also like to just quickly try, whilst I'm here, drawing these as a sprite, because as a sprite it should just work. There shouldn't be any issues with it at all. I just want to confirm that. I might not have even included draw partial sprite. So as a sprite, it should all be boundary and memory aligned, because the whole screen gets drawn as a single quad when it becomes a sprite. So this should be somewhat immune from the window scaling effects, and it does indeed seem to be. Oh, hang on, let's see if I can make that come back. There we go. That's interesting, isn't it? There. Right, let's... can I get that and that on the screen at the same time? So I'm putting that on the edge there. I'm just panning that over, because what I want to see is... Yes. So you can see there... This is... Oh, I can't move the mouse, can I? I've got to keep the mouse still. See how some of the dots on those tiles occupy fewer screen pixels. That's because the graphics card's trying to solve this awkward problem. It's got to allocate 16 pixels across maybe 17 screen pixels, so some have to win and some have to lose. But what we wanted to try and do is solve that in a consistent manner, because then I think that's what's going to get rid of these gaps. Let me put this magnifier back over there for a second. Thank you, Danderstein. Yes, there we go. Now, the zoom shouldn't work because draw partial sprite can only do integer scale. Oh, did I actually implement? I think I did try to implement it. There we go. So this is very interesting. This is telling me, because there's now no hardware involved, so this is telling me that the actual algorithm for positioning the tiles has become somewhat corrupted, and I think this is the case. And I was discussing this with somebody in the Pixel Game Engine chat on the Discord server just last week, that we discovered that I've left in some erroneous flaws, as in FLOOR, as part of the drawing routines. So that's maybe one thing to look at. The other thing to look at, of course, is I'm also drawing these through the tile transform view, so that might also be a source of some of the bugs as well. So we need to sort of follow this through and see where it's going. That's very interesting that it's appearing in the sprite, because in the sprite handling routine, that's entirely handcrafted. Maybe that's actually not a bad thing, because if we can identify in the sprite handling routine what the problem is, maybe we can solve it in hardware too. Oh, interesting stuff. You can see, because we're drawing it as a sprite now, the frame rate absolutely tanks. It's doing some sampling. It's actually a more intelligent draw partial sprite than the one built into the Pixel Game Engine. Good evening, Franzinch. So let's put that back, and let's follow the path of what's happening with our draw partial decal function. I'm going to use the peak definition. I quite like this tool. So draw partial decal is being called in the transformed view first, and all we're passing in are the floating point coordinates. Now, in the transform view, they're sort of always wanting to be integer aligned. So that's okay. We're passing in sort of these x and y coordinates before we draw. But what's going on here? Because we pass in the position, we pass in the decal, and we pass in the source pos and the source size. Now, there's a bit of trick with the scaling here. That I don't think is an issue for us today. That's affecting the rectangular region that's chosen for sampling by the graphics card. Maybe that's a problem, but not the one I think we're going to be worrying about. So all we can see straight away is that the draw partial decal for the transform view immediately calls the PGE draw partial decal. It just does a little bit of translation with this world to screen. So let's have a look at world to screen. And now you can start to see things where I've tried to hack things to try and make this work. So this is one of the things I wanted to do today, is tidy up some of these files, because I've got all of these bits and pieces that I've been sticking in here. And this was a hack that we actually applied to Space Thing to make Space Thing work. Because there's another problem with the Pixel Game Engine too, and we'll demonstrate that in a minute. So I'm going to take that and put that back in, just for the time being. So this should now attempt to round the decals to be at least on pixel boundary. So we'll never send the decals coordinate which isn't pixel aligned, I think. Is that right? Maybe not. Maybe not, actually. We'll have a look. See, decals and graphics using the graphics card, they typically work in this normalized screen space. So at some point, I'm translating my screen to this normalized screen space. But the Pixel Game Engine works in pixels, so it's actually doing this and then doing it again. Right, so panning around seems to be okay, but it's made absolutely no effect to the zooming. Now, there's another little problem that I want to sort of bring in, a bit of a diversion already. We'll come back to that in a sec. If I just go and draw a regular decal, that's what I want to try and do now. Yeah, so we just want to just draw normal decal. What's the easiest way? I'm going to draw it wherever the mouse is. Is that sensible? Is that a sensible thing to do? No, it's not. Not what I want to test. So, okay, let's just draw a decal. So, draw a decal. And I want to draw it at 0.0. GFX time. I'm just going to draw the whole thing with nothing fancy applied to it. I'm going to just stop this for a second, because one of the things I got rid of, and I can't remember where or how I got rid of it, was sub-pixel rendering, which decals always allowed you to do. And then at some point they became clamped to screen pixels. So that's rendering the decal, that's fine. We probably want to, well, okay, what I want to do now is lower the resolution of the Pixel Game Engine considerably. So I'm going to change that to, that's a 32 by 32 pixel image. So let's change this to 64 by 64. And we'll change that to being 10 by 10 screens, so really big pixels that we should be able to see. So there's a very low resolution Pixel Game Engine now. There we go. And the idea is that decals don't need to obey the screen's pixel boundaries. So everything in the Pixel Game Engine is deliberately pixelated. That's the aesthetic that it goes for. But decals would allow you to sort of, at the moment, you can see the individual pixels. There we go. But a decal should allow you to position the decal in between other pixels. So that's exactly what I'm going to try and do. I'm going to draw the decal again. And this time, I'm going to draw it overlapping the middle. So if I draw this at 16 by 16, what we should see is the two decals just on top of each other. But shifted in the bottom corner. So there they go. They line up nicely. Now, in a older version of the Pixel Game Engine, I could specify 16.5 by 16.5. And you see, it would allow me to render that, and it would be fine. Now it doesn't. Right, so now something is clamping those decals directly to screen pixels. So that's a feature I actually want to bring back. I don't want my decals to necessarily be restricted to the screen pixels. And this fix, he says with in quotations, was an attempt to try and get rid of this tiling artifact, and as you can see, it didn't work. So I want to undo that and at least allow me to have sub-pixel rendering back again. Bonjour amigos, hello, what's this? Yeah, we're fixing some bugs tonight. We're having a look at a common complaint, not just with the Pixel Game Engine, but lots of rendering engines, when you're rendering tiles in 2D space, that you get artifacts in between them. Morris, thank you very much. Yeah, see, I think Danderstein's kind of right. That's the problem. It has this silly flaw in, and that's where the problem I think all begins. So we'll go and take that out because I don't know why that crept into the Pixel game engine, but it did, and it was a mistake. It never should have done. So if I go and find the draw decal routines, so I always operate on one version ahead of the rest of the world because then that becomes the version that gets released. Here we go. So draw decal. I at some point have decided in my infinite wisdom to put the standard floor operator in here, and I think that's just a mistake. I just don't think we want that at all. And the worst part is I don't think it's for everything that's decal related either. So it's for that one, it is for that one, it is for that one. But then these ones, the draw explicit decals, it's not there. Draw polygon decal, it's not there. Draw line decal, it's not there. So if I use these decal methods, then that restriction doesn't apply. Now it might be that we do want it to have some sort of constraint, so I might actually leverage this cohesive mode Pixel game engine version to handle that. But for now I'm going to take out the standard flaw on all of these because I just don't think it wasn't there originally. It's not the effect that I'm going for. But we might need to replace this with a slightly more intelligent rounding higher up in the stream before we get to this sort of rendering point. So let's take that out and that out. And that out, and that out. Now, this is a bug. I don't know when it got introduced. I'm sure there are some Git aficionados can tell me which version. But the chatter that's been going on in the... there we go. So, yes, introduced around 2.10, 2.11. I redid the... Ethereal. Yeah, exactly. That's a good one. That. You might want to round it to an actual screen pixel as opposed to PGE pixel. Well, that's the trick, and that's exactly what I ended up doing on the meaningless cog. That's why inside the Pixel game engine there are now some additional functions which allow you to get the nature of how the window is shown on the screen, so you can actually work out the pixel size. And that's what I want to try doing, because there's literally no point in rendering in between the screen pixels. None at all, unless you've got some interesting blurring effects going on, which could be a problem with the shader plugin later on. Anyway, we're digressing all the time. We're diverging from the problem we're trying to fix. So we've made a little change there to the Pixel game engine. We've took out this flaw thing. So let's run our code again, and that should allow us to effectively break the rules of the Pixel game engine. We should be able to position a decal not aligned to in-game pixels, and that's always been the intention of decals. And there we go, perfect. So we can see that the boundary of this white and black tile here is actually 1 pixel wide, but it certainly looks like half a pixel. In fact, hang on a second, I can bring this back in because this is quite useful now. So this is 1 engine pixel wide, but the boundary here is certainly half a game engine pixel. So we've now removed that limitation. So that's a positive thing, because that takes us back to a version of the Pixel game engine which had a lot of interesting features. People liked that because if you do operate in low resolutions, it can actually be quite jarring having the imagery moving in full game engine pixels. I found this in my platform game that I made at the command prompt. In the command prompt, you don't have a choice. You've got to have these big, chunky, square pixels. And as I was scrolling across the screen at speed, I actually found it was a little bit nauseating because it's making these huge jumps. Diverging again. When I was making my NES emulator, I thought the same thing when I was playing Super Mario. I was looking at staring so intently at the screen, I was thinking, surely, is the NES doing something else, doing something clever? And no, it's just relying on blurry screens back in the day to sort of handle that for you. But it doesn't look nice at all when you're panning across a low-resolution image like this and everything is moving in whole pixel chunks. Your brain just can't take it in. It's very uncomfortable to watch. And that was one of the motivations to allow decals to be able to be smoothly transitioned around on the screen. Because us modern gamers on higher definition screens with higher frame rates, we kind of expect this smoothness, and I think it's kind of built into our psyche as gamers. Space transformations is such a nightmare. They are, yes, but you know, it's got to be done. So I'm just having a quick glance. Oh, there's the yes, this is TGD's Exile thing. It's good stuff. It's well worth checking out. There's a link on the Discord CodeZone chat, and I think it's been posted also in the Twitch chat too. Right, so good. So that's the first problem fixed. So let's go and let's make a note of that, because that's the behavior I want the Pixel game engine to have. If we're going to deviate from that behavior, then we're going to do that manually. So if I've made a change like that, I always like to sort of make a little thing here. So we've added reintroduced sub-pixel decals. Excellent. The other major change that I've made so far is clipping for the drawline functions. I did talk about that in a previous episode with about space thing, where you can now draw lines in sprite mode and they're clipped. So if you ended up zooming in, things in like the 3D rasterizing stuff, if you ended up with a line very close to the camera, it could end up being billions of pixels long, and it would, of course, kill your frame rate. But now it's clipped to visible screen. Right. So I don't think changing that will necessarily change anything regarding our initial problem, but at least we're starting on a common ground. Oh, got to change the resolution back. But hey, low resolution, that's okay. It's actually showing us what the problem is. So now it looks like we physically can't specify the decals to be at the correct location. Now, is that because just in the transform view now we've also put this floor back in? So let's go back to the transform view. Where was it? World to screen. World to screen. So I just want to take that out. I want to make sure there's nothing. I'm going right back to basics here. I want to make sure there's nothing clever going on. Right. So what is clamping that now to a specific screen pixel? And I think that's where we need to start investigating. However, we seem to have miraculously solved the start of the line artifacts. No idea, right? No idea. We need to understand what the problem is there before we continue. But that's certainly now. Oh, it's not quite locked into a pixel. See, there's something very strange going on there. Oh, there we go. We did actually have a line artifact sort of pop in. Now, that's the more common problem that people have, is most of the time it works perfectly fine. It looks great. Although I still don't know why it's clamping to one screen pixel. We'll have to investigate that. See, why is it moved as well? So why is this origin moved now to like half a pixel? What's going on there? Lots of things we need to look at here. When you're at sort of silly zooms, then patterns like this, you got to expect to see. We have no sort of sampling algorithm, so I'm not too bothered about things looking a bit strange when you're fully zoomed out. But it's when you're zoomed in and you start to see these artifacts, I'm a bit worried. So I think the problem I want to solve now is, why is this clamping to a single pixel? What's going on there? And it could well be that it's the get mouse function, because I'm just... the transform view that I'm passing in has no understanding of... it's basically passing in the mouse coordinates. So it could be that's the problem there. And is it when I go off screen that it changes the nature of that gap at the edge? Don't know. It's a bit strange when we're looking at sort of individual pixels. Let me just bring in the magnifier again. Give people a chance to have a look. So the problem I've got is it's still clamping to a single pixel. Now, I think that's actually more to do with the limitations of the mouse coordinates that I'm passing into the transform view. Also, rather frustratingly, I can't make it do the artifact. There are certain. Oh, see, it did it then, but I kept on zooming. So let's just keep. Let me find. If I just keep zooming and just try it, and if we get lucky and I can stop fast enough, we might be able to see it. That's half the problem with this bug. That's why most people will quite happily go and tile something, no problems at all, until one day they just happen to find that correct combination of zoom and it all falls apart. Not always that easy to pick out. What I'm going to try and do is put the Pixel Game Engine back to a slightly higher resolution one, because I think that increases our odds of getting this. What did I have it at? 540 by 480, 2 by 2. We had one. Sorry, but you keep on zooming. This is not a very exciting stream, is it? Zooming in on a black and white grid. Basically, I'm hypnotizing you all into donating, of course. It's all a secret ploy. I see I could be here all night trying to make it do this deliberately. There we go. Okay, right. Managed to make it happen. So interesting. There we go. So now you see there's an artifact, and look, it's strange, right? So this artifact is no longer consistent with what's really going on. Now that's not just the blurring algorithm of the magnifier. I can physically see that on the real screen as well. Now this bug we've always attributed to being a sampling error in OpenGL. I'm unsure. I think it can be that, but I'm confused as to why you see the cyan in the background. That means it's obviously not putting the polygon edge, because these are all individual polygons, pair of triangles forming a quad. It's obviously not putting that edge in the same place as the start of the next one, but it is here. And look, it's doing that. We can see these top two dots are squashed relative to the bottom two. So that one's fine, that one's fine, this one's squashed, and there's a black mark. This one's also squashed, this one's squashed the other way. Squash, squash, there's no consistency to it. Very strange. But also incredibly frustrating, because people write these tile renderers and they think, oh, I've done it all right, my level looks great, I've got a really nice graphics pack, I'm going to go and render it, and it just looks like an abysmal mess. And want to try and rectify this problem. Are you doing the 0.375 offset trick? Not yet, and they're the things I want to try and avoid. I want to try and do it without resorting to sort of numerical rounding hacks. It's numerical rounding that started to get me into some trouble in the first place, although I'm not ruling anything out. I do want to come up with a solution that's a bit more digestible than that for the meaningless cog game. Drawing 100 recs through drawRec function off screen is faster than doing the same with drawRec decal. Depends. Spooky stretchy problems. Yes, spooky stretchy problems. Well, I mean, yes, understandable spooky stretchy problems, but that is very strange, right? Why does it suddenly change for those rows? I've no idea, and that's why I think we're sort of fighting two problems. One is some dodgy maths with the rounding of where the quads go, and the second is I think OpenGL just doesn't know what to do. And we might need to bias it slightly to give it a helping hand. Record this zoom and offset to repeat the error testing solutions. Yeah, that's easier said than done. The decals will always create a draw call for the GPU. Yes. Yeah, I said people sort of go, oh, you've got loads and loads of draw calls. If you're writing a 2D game and you need to draw 10,000 objects on the screen, PGE will do that, and it will do it at 100 and something frames per second. But you've got to put that into perspective. If you're drawing 10,000 objects on the screen in a 2D game, you're doing something wrong, right? Because even the most richly detailed games, 10,000 on-screen objects is a phenomenal amount of objects. Even if you had the most organic, high-definition game possible, you had leaves falling and sparkles everywhere, and like 10,000 of them is unwieldy, and PG will quite happily render that. So I don't buy too much into this is slower than that argument. I think there's for 2D stuff there's enough. Well, even particles, even 10,000 particles on the screen at once. Bullet hell games you might get to a few hundred, right? But you're never going to get to 10,000. Yeah, tricky one. I'm sorry, I keep forgetting the magnifyings there whilst I'm waving the mouse around. Right, okay, so interesting results so far. So we've managed to sort of make it draw things in the right place. The restriction on the pixel, I think, is because the mouse coordinates come in game pixels, not in actual window pixels. Now, I'm okay with that, actually. That's not necessarily a problem, because what I could do to make that visible is I could put keyboard commands on it and actually have a little character moving to the left and to the right. And we would then start to see whether it works, and I think it would be moving smoothly in that case. So I'm not too fussed about that. I think we've fixed the sub-pixel decaling for now. Happy with that. So the next problem is trying to sort out this artifact. And it's strange that there are certain situations where it's far more visible than others. And just, I don't want to... Yeah, we need to find a reliable way to capture these things. And that's not always that easy. So let's go and have a look now at the... Well, we were following it through, weren't we? So we were in transform view, we went to world to screen, and we added in this sort of hack to round it to the nearest screen pixel, and that didn't work. In fact, that actually caused us some problems. So let's just go back and we can. What's this? This is a method of debugging. What's this attack called when you're actually introducing bugs to show the differences? Right, so why do we get the effect that we get here? And that's because everything has to go onto perfect pixels. At some point, something wins the battle or something loses the battle. But this one is a bit more interesting. Because this one here, I'll bring in the thing again. Why is this interesting? Because we've seen that I can only pan the image around to whole pixels. The routine here that draws the decals is rotating to is rounding to, well, the nearest integer pixel. So that's in the game space. So how come we've got gaps which are 1 screen pixel wide? That's quite curious. I don't think I can readily explain that. I could understand them being like this, which is... I guess it depends on the zoom level, doesn't it? It really does depend on the zoom. See, they're kind of zoom agnostic, and that's what's bothering me slightly. Because nowhere in the system now am I rounding to actual screen pixels. Something else is somewhere. This is rendering to game engine pixels, world to screen, but it's not rendering it to. It's not converting it to actual screen pixels. So how do we get this 1 screen pixel gap? Don't know. Yeah, so standard. That's the problem. Yeah, you're right, Morris. Standard floor is this is wrong, right? This is not the correct implementation here. You should update your application to show the zoom level. Hang on, just going back on some of the chats here. Rounding errors between the tile and the view transform. Yeah, well, before we had the transform view sort of in place, these things have always sort of, it's been here. These artifacts have always been in decals. The 0.375 offset trick is the OpenGL programming guide. So go on, somebody, yeah, don't post a link to the whole book. Just post a link to the trick, and we'll see if that we can try it, give it a go, see what it's about. It's like Z fighting, but for 2D, kind of. I mean, what we've just seen there is I don't know how it knows that a screen pixel exists, because nowhere in my system have I told it that a screen pixel exists. At least I don't think I have. I can't remember. Possibly in the scaling routines, maybe, of the decal. Let's go and have a look. Where was decal stuff? Decal stuff was about here. There we are. So I do have here the inverse of the screen size. Okay. Inverse screen size. I need to remember what this is. I need to go and find it. What is this? I don't think this is actual window size. I think this is... Let's go up here. Where is it defined? Inverse screen size. Yeah, inverse screen size. This is the size of the game engine pixels. So it's actually nothing to do with the screen. That's what I suspected. So you set screen size. It's here even so. It's relative to the game engine pixels, not my monitor's pixels. But what we see as the artifact is clearly one monitor pixel wide. I want to know how it knows. Translate x and y by 0.375 as shown in the following code fragment. Such a translation keeps polygon and pixel images safely away from the center of pixels whilst moving line vertices close enough to pixel centers. Zooming 16 pixels 2 times is 19.36. How have you got to that? You round the next tile position to 20, but the tile itself is just 19.36 pixels large. Hence the gap. Yeah, I think that's actually probably right. I don't know how you've got to 19.36 from 16 times 2, but I think your principle is probably about right. Yeah, so we're ending up in a situation where the scale of the quad isn't quite enough to get us over that halfway mark to fill in the gap. Minson56, hello. Yes, well, you do now. There we go. It's very different to the YouTube videos. It's far more chaotic. Yeah, it's one. Well, sorry, it is 1.1 in the code. Yeah, so that should be 1.1 times. Yeah. Interesting stuff. Okay, so let's. Okay, we'll try some of these community suggested hacks then. Why not? So it says here that we should be able to just translate x and y by 0.375. Okay, we can do that. Why not? So let's just try. Well, we're using draw partial decal. So let's make sure I'm using the right draw partial decal because they are slightly different. I'm not using this second one, which allows you to sort of specify the target size of the decal. We're using this first one here. So if I go v screen space pos plus equals 0.375. So this potentially would also then nudge over the screen space dimensions as well. Interesting. Okay, let's try that. B screen base pos. No, that's not quite right. So it has to be after the transform, doesn't it? Yeah, okay, no, that's not quite right. That's now we're in the awkward situation where that's in the normalized space. Yeah, I want to do it before there, don't I? I want to do it to this pos, so it's basically this plus 0.375 and this plus 0.375. So what we saw before is the image should have been in the top left, but we saw it was clearly moved off the screen a little bit. Shouldn't be the case. Yeah, Dragon Eye, we're trying to fix this bug that everybody seems to be having. We'll see now straight away. I'll bring in the render before I've even moved anything. What we see with that little offset is everything's moved forward a pixel, right? So it's actually offset too much. So even though that was 0, 0, it was sent to 0.375. Not convinced. Also, no, all the artifacts are still there. Unconvinced. So these are going in game engine pixels. I think they probably need to be converted into actual screen pixels and then offset by 0.375. That's far fiddlier to do. Let's just do a brute force hack and see if we can understand that and see if that is actually the problem. So I know that my game engine pixels here are 2 by 2. So in that case, I should be able to offset by half that amount. This is an awful hack, which is what 15625, is it? Tell you what, beautiful. Right, so that's put it back in the right place. Panning, okay. Start to zoom straight away. I mean, highly visible artifacts again. So that's not really solved the problem. That's just... I mean, it's increased the odds of the problem occurring. Yeah, it's an interesting one, that. Okay, so Quizat77. I think maybe we could try it there, actually, because I do actually have access to the translation. See, that translate F... okay, no, so I'm looking at the code in the switch. That's for the orthographic 2D, so that's actually full screen size pixels. Yeah, we don't really work like that in the Pixel game engine. The artifacts are more consistent. Yeah, so adding that number in has just made the artifacts appear more frequently. So now is it a problem that the size is being underestimated? Well, we can go and explore that too, because we could, in effect, add some additional component to the size as well. So let's try and tie this up a little bit. So float f bodge is going to be this. And I'm also going to make the size 0.375 a little bit bigger as well, and I'll do that here. Interesting that I multiply that by 2. I'm trying to remember why the transform maths was done that particular way. And it's because it goes from -1 to +1, isn't it? That was it. Okay, so plus f bodge plus f bodge. So in effect, is that just going to move the whole thing over? Anyway, let's have a look, see what happens. Okay, so looking good there, looking good under panning. No, makes no difference. Artifacts still there with the zooming. Now, is that because we've also offset the top left? No, I don't think it is. I think this is more the genuine artifact that everybody's been having. It's not that the tiles are necessarily in the wrong place. It's that for whatever reason, OpenGL decides not to render that last set of pixels. And you can kind of see that here in the magnified image. Right? It's chosen, for some daft reason, it's chosen not to render this black line to be the same thickness as the black line opposite. It's not that, you know, the quad is reasonably accurate. It's just for whatever reason it's decided that set of pixels does not belong to the quad that gets drawn. Yeah, Dandesine. That's the interesting thing. That's why it's not exclusively a PGE problem, but I think that the scope to solve it, given that we've got constraints on how we render things anyway, and I think it's to do with the fact that we've now got this this coordinate on the GPU doesn't necessarily line up precisely with a screen pixel, and I think that's where we'll have to put in the solution. And that was messy in Meaningless Cog. That got very messy indeed, but it did work. There are other little hacks you could do. So if I change this the bodge factor, if I change that to something larger, let's see this 0.375. I change that to 0.5. Yeah, no difference. I'm not entirely convinced we're implementing the bodge factor accurately there. So I'm going to make a quick note of the chap's name, and then I'll catch up with some of the chats. So Quizats77. Quizats77. The only reason I do is any sort of like helpers or contributors in any little way, they do actually get a little nod in the Pixel Game Engine. You know, it is on the whole, it's kind of community driven now. Isn't the issue with standard floor that there is no standard floor anywhere now in the chain? The screen pixel is not in any of the triangles, which is frustrating. So that's why I think it can be done. The bodge factor is my favourite TV show. You should round the bottom right tile coordinate to integer. That should fix it. Bottom right tile coordinate to integer. Okay. I think that's sort of how we started this adventure. Because these are, it's a little bit trickier than that, because these then go through to get normalized. And I wonder if that normalizing process is also causing us a fuss. But we can try that. So v screen space dim. See, the thing is, they come in as integers, but the top left might not necessarily be an integer. So what I was doing in meaningless cog is looking at the size per pixel of screen space and then multiplying all of my coordinates by that factor. It's tricky because I've got a feeling if we start doing that, then we lose some of the other desirable features of decals. Well, yeah, the tile dimensions, they're coming in as integers, right? So it's 16 by 16 is the tile dimensions. But they're being added to potentially any value top left coordinate, which then gives you this bottom right coordinate, which could have some floating point offset. So we could, okay, let's try clamping that, but then it's clamping that to something sensible, because at the moment this is all of that ends up being. Does it end up being normalized there, or do I do it later? So that's yeah, so because I'm multiplying by inverse screen size, so I'm changing that to between 0 and 1. So the size here, I don't think it's as simple as that. I think that needs to be done at a slightly different level. I'm just going to change the bodge factor to 0 just to take it out of the equation for now. Okay, let's go and have a look at, maybe we can implement that when we're actually drawing the decal. Slightly different approach. So when we draw the decals here, there we go. So it's just being passed in now as these are the GL commands for the GL 0.1, sorry 1.0 renderer. Pass in our coordinates, but again these are in normalized space. So what I was doing was clamping to in normalized space to the nearest pixel by basically expanding the normalized space again and quantizing it that way. That's what I think I'm going to have to play with. But unfortunately, I've just looked at the clock and our hour is up. So yeah, quite an interesting one. I think this is certainly going to provoke some debate amongst the community because it's a problem we're all frustrated by. And it's frustrating when you actually see an implementation of a side-scrolling platform game and it doesn't have these artifacts. So what is necessarily causing these artifacts, and how do we mitigate against it? And what I don't want to end up doing is doctoring textures. I think there's genuinely a maths way to solve this problem. So yes, for those of you who have joined tonight, these streams are only an hour long. It's all I can afford to do because I can already hear Javid X10 screaming for my attention. So with that, I wish you all good night, and I will see you when I see you next. Of course, I'm on the Discord for a chat. So thanks for stopping by, and take care of yourselves. Bye-bye.